All right, so yeah, welcome to the Women Who Code Singapore event. So today we have Natalie to join us, an amazing speaker. She'll be talking about CI/CD and GitOps. And before we start, I actually would like to give like a short introduction about Women Who Code and myself. So yes, I'm Stella. I'm your host for today. And so what is actually Women Who Code? We have a mission. Our mission is to empower diverse women to excel in technology careers. And the vision that we have is that we want to ensure that diverse women and historically excluded people generally can thrive at every level in any of the tech industry. So we do have values that we embedded in our organization. So these are like the 4 values that we have. Is 1, we focus on our mission. Always remember why we are here and who we are here from. Design for inclusion. We always try to make space, embody the culture of belongings. We always advocate for change. We live for leadership, champion each other as a community. And lastly is about journey forward. We always remember to recharge, celebrate our wins, and break our barriers. So without further ado, let me introduce you, Natalie. So Natalie is actually a staff cloud engineer at Altruis. She enjoys building and automating various tools that help her development team to be more productive, as well as to make them happier. So she loves working in environments that are fast-paced, creative, and team-oriented. So she loves new challenges as well. She's passionate about making infrastructure more accessible. She loves solving hard problems and everything about containers. So you folks have an opportunity to ask a lot of questions about this. And additionally, she's as well likes to write blogs and speaks in many conferences. She's a technical mentor as well. So she loves to help others in building their career development, as well as like self-improvement, and help them to hone their soft skills. So Natalie knows how to have fun as well. So in her spare time, she loves to hike and camp with her Aussie Doodle, and I believe it's a goat. Yeah, so it's called Chai. And so she loves to do stand-up paddling across the bay as well. I've never done it before. I really wish to try it. It sounds fun. So yeah, without further ado, let me just pass over the presentation to Natalie. You can actually share your screen and then start the exciting topic today. Hold on, let me stop sharing.
All right, let me try that. Let's do it this way. I wanted to share some code and examples, so I will be switching between those windows. And with Zoom, it's usually over your presentation, so please bear with me. Let me just go on the first side, excuse me. So
no problem.
Thank you so much for the introduction, Stella, and thank you everyone for attending this meetup. I hope you will enjoy today's talk, and please feel free to ask any questions. I also feel like if there is any questions in the future anyone might have, I'm going to leave my email here, and please don't hesitate to ask them if, for example, during this meetup, you didn't get a chance or you didn't have any questions. So my name is Natalie, and today's talk, you can see my screen, right? I cannot see my own screen, so it's a bit complicated. Okay, so basically, can you see the window with attendees on the right side? Shall I move it? Or?
Yes, but I also can see your slides.
Okay, let me just change the windows so everyone can actually enjoy it and not get distracted. We can do it the other way around as well. Hopefully that will work better. So share my screen. Okay. So it should be better now. Okay. We will move this window here and we'll do it like this. I hope this is better now.
Yeah, it's good.
Okay. So my name is Natalie. I do work as a staff cloud engineer at a company called Altruist. I have been in the industry for quite a long time. I started like before DevOps journey. I was mostly working in networking and still writing a lot of different type of code related to like networking, testing, and infrastructure around clusters and switches. And then later I transitioned to DevOps, which became like more part of the industry. I use a lot of Python for work. I started some Rust. That's why some examples today will be in Rust. And I don't use much Twitter these days, but if you want to find me on social media, please use this handle. So what are we going to talk about? It's going to be a little bit touching on CI/CD concepts. There will be more focus on GitOps. I will try to provide some app examples, which I don't want to overwhelm anyone with like different tooling and UIs. So most likely it's going to be just a part of the code and how it's used, how the apps are designed. And obviously, except examples, we're going to go into like some usages where we should use certain things when we're thinking about services. So the entire presentation will be covering the idea of deploying certain app, right? So to give you an idea, like every day at work with releasing certain services or applications, it could be web services, could be some small things like some queue processing service, or could be something called, you probably heard of Lambdas, or some like serverless application where they just do some one function and they just exit. So all this is considered a service. And apart from writing code, we usually packaging them and then we put them in certain cloud, for example, and we run tests on them. And all this is called DevOps culture these days, right? When industry started, we had CI, which was like when we transitioned from the old monorepo and old system of deploying things, moving to the microservices/services infrastructure, we start using concepts like CI, CD. CI was more when you have your service and you're trying to deploy it, build it. When we have CD, this is when you're trying to deploy the service in a certain environment, right? So basically a lot of companies, I don't want to say every, but majority of the companies trying to adopt the culture called DevOps. And basically what it means is that we deploy those services every day in our company, at work, multiple times, right? Usually just if someone trying to understand the scope, let's say if I try to just give you an idea of like of the GitHub repo, right? We can have a repo like that where we create some kind of a Lambda, right? Our Lambda, sorry, for some reason GitHub is slow for me. Our Lambda will have certain files, supported files. It will have a source code. And basically this is, and like if I'm going to show you the part of the code, which called example 1, usually when you start writing your application as an engineer, you will put some code in it, you will package it as some kind of application. And these days we're trying to put everything in containers, right? I'm not going to go in details what is Docker, what kind of containers are we using and things like that, but just to give you an idea of what I'm trying to talk about. So how is usual CI workflow look like is, as I already said, we wrote the code, we push it into our repo, we run the test, we found some bugs, we did the same job again. We get to the condition when we feel it's good. We created the package of it, we push it into some ECR repo, which is the same kind of GitHub repo, just in the cloud with the Docker. We did the automation, and then something happened to deploy our app to the cloud. So this concept, it kind of includes CI, CD. So everything around packaging is CI, and then we push it to CD. This model is called a pull model. What it means is every action we do, we most of the time pulling. We change in certain state, right? And we push our CI to do certain things. So basically, there is a change in like everything we do is something we simulate. And for example, when we have this Docker container, which push to ECR, most of the companies these days, they use Kubernetes, right? Where these containers later is taken and uploaded to a certain environment where multiple services run, and this is what we call actual infrastructure. So now a lot of companies start using GitOps, and some of you might think, is it just a new buzzword? Which I also probably had the same question when I just started learning about it. Do we actually need it? Is it exist? Is it a new term? So considering the workflow I spoke before, where in my repo I had primarily just the code with a certain bit of a packaging, the GitOps, right? If I tell you what it means, is basically it provisions infrastructure where we deploy things. So previously I said we push this Docker container is some kind of virtual ECR repo, right? And something takes that code, that package, that image, and deploy it to Kubernetes, for example, right? So for people who work in infrastructure for us, right, we usually know that Kubernetes runs on something. It runs on cloud, it runs on some kind of infrastructure. It could be on-prem, doesn't always necessarily has to be a service. Sometimes it's a service provided by cloud provider. In Microsoft world, it's called Azure. In GCP, it's called, in Google, it's called GCP, and in AWS, we call it EKS, right? And basically for GitOps concept, we add in more complexity by saying that now I want in my repo have infrastructure as well. So basically the logic of developer who going to develop the app now expands into more, not just write the code, not just run the test, not only do some integrational testing, not only push the image somewhere, that something's supposed to take that image and add it to the actual infrastructure ecosystem. Now, all this infrastructure also part of our project. And this is what kind of how GitOps extended in a way that teams can use it on the daily basis. They still continue using Agile. And again, going back to the code. So here, is it visible? Shall I zoom it more?
Maybe you can zoom a little bit more.
Let me try to zoom. So
yeah.
So basically, in example number one, we had just a basic Rust application. It was packaged in with Cargo, which is Rust package management, and then we put it in the Docker container. If I'm going to show you example number two already have more in this repository, right? Let me just make it more visible. So it has the source code, it has a test, it has also a Cargo, it has some packaging. And here we added GitHub, which is the old, I don't want to say old, but previous way where development process was not GitOps, it was called CI/CD, where we had, in this example, I used GitHub Actions, where in my deployment workflows, I created CD and CI files, where it's like, this is just an example, so there is not a lot of logic, obviously, where I have some main branch, which has some basic environment, variable setup, and then there are a bunch of jobs where I deploy Ubuntu container, I check some coverage, and then I deploy, and then I lint my code, right? And then my CD would be taking something and run things on Ubuntu, on Windows, on whatever operating system, for example, and then would publish my image and the magic would happen after that, right? So with the GitOps, the way how repository would work, there are different ways, right? So infrastructure as a code, right now I spoke about things like Kubernetes, where most of the time it consists of certain manifest, which happen to be described as a YAML file most of the time. And I don't know if someone is not familiar with Kubernetes. There is a Kubernetes.io. Excuse me, Kubernetes.io, and I might misspell it because when you're presenting it, where you can find all the description as well as all those YAML file and configuration examples, and basically you don't, sorry, excuse me, deployments, where you don't need to know how these YAML files look like. If you work with it a lot, obviously, you kind of get an idea, but all this is a standard. It's called manifest and configuration. So going back to our slides, is that I was just saying that I gave example of Kubernetes, but in some cases, there are type of service like Lambda where we don't use Kubernetes, right? It's a separate service. It runs on a different environment, where in that case, our config files look like more like a, for example, HCL file, and they deploy with a tool called Terraform. So based on what I just said, what GitOps is basically it's a set of practices around certain services, right? Where every engineer developer can still perform the irregular tasks to get the job done in a way where they're not just doing the CD within the local repo, but it's more expanded in actual environment, which can be represented in certain configurations. It could be, as I said, YAML file, HCL file, which is called infrastructure as a code most of the time. And basically a subset of those different tools within the repo creates this whole GitOps approach of deploying the service. And the interesting principles of following that culture, it's also called culture, that this is also declarative. So everything is in our source code, everything in the repo, everything is versioned. So every commit helps us understand what was changed, not just with the app, but as well as in infrastructure around the app. It pulled automatically. What it means that there is industry provided tools. Like let's say for CI, we use GitHub Action, we use GitLab. There is a lot of tools like Circle CI, you probably heard some of them. There is famous Jenkins. For CD, we had a huge, I would say, industry-changing tool called Spinnaker, right? And in the GitOps world, we also have new tooling, which is Argo CD as well as Flux. There's like CodeFresh, there's a bunch of them, right? They all have similar concept where they kind of monitor your repo in the way that you set it up. And basically they pull the changes once someone pushes them. So once something gets approved on main, there is a like different way how you set them up, and your changes immediately after going through the CI/CD process get deployed. And then, as I said, there's a still amount of tooling that we can choose. And apart from that, which is very interesting, now with all the tooling, you can set up. You are, as an engineer, in control of your environment. So here on example number 3, I still have, let me just open it. I still have my Rust application, which is a bit complicated than the previous one. I still have my Docker container, but here in my environment, I can say, please deploy this to the development. Please deploy this to the staging. So now I have more control where I want to deploy. Here I set up development environment, where I'm actually deploying a Rust service called Lambda, which does certain image processing, for example, right? And I do it with a Terraform. So it's another form of representing infrastructure as a code. I have, again, I'm not going to teach anyone Terraform or RCL code, but basically there is some main file which just describes my config in a way what resources I use in the cloud. Currently in AWS, as we can see, I use AWS provider. And this is like a Lego puzzle, the resources I need. Again, if someone is interested, all this YAML or CL files, there is obviously Terraform site where everyone sorry, this is the registry, but terraform.io is how you can start. HashiCorp provides like ways how to start with it, how to make those tools. And so all the documentation is pretty good and all these tutorials are available. So that's why I don't want to go into the details, but the main point is now in accept the code, which is like contains of certain settings, certain configs. I also setting up environment.
Sorry, Natalie, could you actually zoom it? Thank you.
Okay, yeah, so basically here I have certain, like I have a bucket, which is just a setting. Like say in the cloud, I can create a S3 bucket. I am zooming in. I hope this is enough. And as I said, there is a Terraform configuration. There is the AWS provider I use. There is a region. Again, if you use cloud often, you probably know that certain things we use in the different regions. I probably can show you some, just to give an idea that all this in this file, no, I'm not logged in and it's going to take some time. All information in this file is just describing my configuration. And then it's going to fail, but just because I'm not logged in, I can just say that this app can be deployed with Argo, for example, or everyone can create certain make file, right? I still have a Docker file. And for me to run this in my make command or in my README, I basically have something called make is a very standard tool. I prefer to use it because it works on every platform. But if you don't want to use, excuse me, I just need to go into my example.
Natalie, sorry.
Yes, more.
Seems like can you maximize the project structure on the IDE itself? I think someone want to see the structure.
I would love that if someone can help me. I unfortunately don't know how to do that. Maybe this is better.
Yeah.
Okay.
Yes.
Okay. Apparently, I know. I was sure. Okay, so I hope this is enough now.
Yes, it's good.
Okay, so basically, we are looking at example number 3, right? So for people, apologize who was not able to see, the example 1 is just basic source code, and there is just packaged in a Docker file. Example 2 contains only GitHub, and here we're providing CI/CD scripts to deploy our application. Now we are looking at example number 4, example number 3, where we have a same app. In my case, it's a bit different app, but basically it could be any app, right? Still have a source code. There's some logging, there is some testing. You still have a packaging. Rust uses cargo. There's still a Docker file where actually in this case, I provide environment, and in my Argo CD or Flux or any other tool I use or GitLab, I can say, deploy this environment, which could be a dev in my case. And with that, I can push some parameters, like let's say amount of servers I want to have, or amount of, I don't know, anything. So basically all the settings can be configured for the stage in a way that here in my infrastructure repository, I have some Terraform code, which I said is just not going to cover it, but it's basically a config file where I describe my infrastructure. And in my environments folder, I created the dev environment where I have certain configuration. And in this case, I'm just passing a bucket name, which is a S3 bucket will be created because that service needs that infrastructure, and like just certain log settings for specific app, right? And then I said, if I go into my example 3, in my README, in my make file, I have these commands, which actually do Terraform in it. Like it's not related to this talk, but it's basically configuring my Terraform. But in my make file, I can just use this command, right? And I can start deploying the Terraform. So this should be done with the CI tool, only that this way we follow in the GitOps practices, where our CI tool after PR is merged, doing all the job for us. And here, what it will output just basically a lot of things. It will let us know what it does. So going back to the slides, and we don't have to wait for that to finish. It's also going to take some time. So we covered the principles, and the typical workflow is a bit different now, right? Except that we're doing a pull request engineer developer responsible for the infrastructure. Obviously, you can work with the DevOps in your company. You should work with DevOps or infrastructure team or SRE team, whatever name it has. And then everything you push into the repo will not need anything manual. It doesn't need any monitoring around the actual deploy. So the tool you're using should automatically pick the changes and deploy to environment that you provided. Obviously, you don't have to deploy to all the environments at the same time. Your company can have staging, dev, end-to-end, demo, and with all this tooling, you can play around it. The beauty of it that they're all going to be always the same. There will never be a manual changes, and they will be easy. Let's say roll back something from it when something fails, or let's say there was a case when once a region in the cloud, for example, AWS had a maintenance, and you can replicate easily those environments in any other region, just providing the proper different settings. So this is basically GitOps in a nutshell, I call it. This image is taken from gitops.com site, its official site. It's still something called CI/CD. So all the concepts of this apply. And basically, your pipeline just runs in a serious task. Your pipeline will look like much more complicated. Some people call it workloads. It's not going to be just a simple script. And here is an example of how we how implementation is separated. So the difference comes here when you have a trigger which just triggers your deploy, and some magic will happen. Whereas in the GitOps approach, we know which tool reading our config files and representing them in the deployment type we want. Is it the cloud? Is it Terraform? Is it Kubernetes or anything else? So what's the difference, right? Why sometimes we want to use GitOps, why sometimes we don't want to use GitOps. So as I said, pipelines and workflows are becoming more complicated, and not every company can afford the engineers actually spending time using GitOps. I would say from my experience, it's harder to start with GitOps. Basically, a lot of learning curve comes now, and people need to switch their mindset into not just thinking about writing the code, but also about deploying, right? A lot of people have to get to an idea when you deploy, when everything deployed on your push, in some cases it's harder to debug, as well as it's easier to fail, we call it. But basically, once your code gets to development faster, it's easier and faster for you to find the bug, right? The faster QA team can jump on it and test it, the faster code can get to production. In GitOps, because GitLab has this concept of MR, sometimes we call them merge requests, sometimes we call them PR. It's totally the same thing. It's just different platforms call them differently. It's still going through the review process. In certain companies, there is a good practice when you want to tag someone in infrastructures or your DevOps teams so they can help you and just validate that your configuration is written correctly. What I mean by that, in this case, it's not only DevOps team. And everything is done with the Git workflow, so you get more flexibility on how you design, how complex it is, how fast it fails, how many environment gets deployed at the same time. There is more control over your production, or sometimes company uses something called demo, right? When you trying to save your cost, so you don't deploy demo every time. But if you have a customer demo, you can come to your job on Monday, for example, deploy this cluster, do a demo, let marketing team do a sales, and sales team do a sales and market and demo and all the things you need. And then you can spawn it back just by using all the automation in your workflows. And then, as I said, there is a lot of components. There are two types of GitOps. We still support pull as well as we support push. And in CI system, we don't use that because the amount of scripting we have to do and resources and config is harder to maintain. So this is only using GitOps approach. So a company can have CI/CD and that's it basically. Or you can add the something called GitOps, which is more exposed. And let's say if someone starts using GitOps, how do we start practicing this? Let's say if team wants to move to GitOps. So basically managing repositories. So in this case, it's really crucial what goes into main, right? So you probably want have some settings around it. Again, with the GitOps, you can even have some configuration and conditions where you deploy to main. You're kind of moving more towards agile when you deploy. You less have of like I call it old school, but waterfall approach releases when it happens once a month or once in 6 months. It's practically impossible because people will make changes more often. You will have more infrastructure affected changes. So you want them as fast as possible to get to the reality. So your source code actually matches what in your production, right? Versus if you do releases once in 6 months, you have a very big gap. And when you start merging all of it, everything fails. So in this case, there is like a negative effect when not just your code going to fail, but also your environment going to fail because it's really outdated and some version can be like not supported. If we're going back to example of Kubernetes, let's say there could be some resource like core DNS, which could be already outdated in 6 months, right? And then in this case, you will have to go and update each single application, some versions in their specs to match this version of the Kubernetes core DNS resource. So in this case, GitOps approach is basically push to main. If you fail, recover fast and make sure your source code management is matching what is in your production. And then this creates consistency and standardization. What it means that everything you commit has a specific version. Everyone knows what goes in this change log. And basically everyone across the company has access to the same understanding and can visualize what is currently running in production. And of course, reliability, which is very important, that if something go wrong and you have all the versions, right, it's easy to revert to the previous version, which is also part of CI/CD logic. But in this case, you don't have to, it's more controlled, right? You can, for example, keep this in dev, but revert in production. And obviously the auditing these days, security and auditing is very important. And by having the version standard and everything in source code matching your production. So you don't have any more production environment in the cloud or on-prem where someone added something manually, because all this tooling, for example, Argo CD or Flex, they pull in everything from the repo. And if someone edits something manually, they check the state and they revert all these changes automatically. So no human need to go and do that and basically wasting their time. So in summary, GitOps is operating model that provides us with, I would say, better practices where we do similar Git deployments. We still do the management. We still can do containerization. We can release any type of application, but in a way that it's more structured, it's more reliable, it's more into one repo. It's more into everything around the application located in one repository, which is in one place. And basically now engineers, developers can have more power, right? Because they have a visualization, what are they deploying? So remember when in the beginning I said that GitOps could be a buzzword? We don't know. So we did kind of a dig in and understanding like what is the difference. I can say that in my opinion, GitOps makes it easier for engineers, for infrastructure people, for everyone who touches the code any way or the other way in the company, as well as a lot of companies moving not just to the different clusters, but multi-clouds, right? In this way, you still have all your configs in one repo, which makes it amazing. In the past, you would have to understand, look in different repos and see like, where is my code, what gets deployed. With GitOps, it's actually much easier. Specifically, infrastructure as a code becoming more useful, which is a very important concept nowadays. I feel like it's going to be a future where more people will start using string config files in order to describe not just maybe a cloud or setting, but a lot of things should be like in Kubernetes world, we use a lot of operators and all these configs could just help us to move faster and make our changes deployed much faster. And again, this is pretty cool, excuse me, when they say that when something goes wrong with GitOps, right, and something change, you can always even set up an alert. If something edited something manually, it doesn't mean that everything will be reverted silently. You can set up different alert, different monitoring around activities, and it helps team to understand what was changed and how things were configured. So here is basically, I'm giving a difference between again, this is from GitOps.org side. Everything on this slide is just the way it is, and I don't have to draw or make another diagram because it's pretty easy. You write your code, you design your unit test, you do the functional testing, whatever testing you do, and then you do the deployment. It's a DevOps pipeline. But in GitOps translation, you have exactly the same steps, but now in this image, we have Kubernetes, where the deploy is more controlled and environment also more controlled. And as an engineer, you can control more of it, what goes where and when, right? Preferably all the time, all the environments should match. But I understand that some companies, let's say I work in FinOps industry, where before we go to production, we have to be more thoughtful. We have to run more tests. We need to let our customers know that this change will come. So in some cases, our production can be a little bit, couple days behind the prod, right? Development, which is fine. But when it's like a couple of months, then I don't feel there is an easy way to catch up for such big gap. And with this talk, usually I don't do this, but I just want to clarify some things in the industry which makes this concept confusing. So some people say that if they don't use Kubernetes, can they still use GitOps? Yes, you can. And I try to give example in this talk that you don't need to only have a Kubernetes manifest. You can have something like Terraform, and you can still use GitOps to deploy that. Also, you can manage Kubernetes with Terraform. There is also tools like Helm. So all this can be done with GitOps, and this is pretty cool. So please don't feel like you need to use GitOps and Kubernetes only this way or only both of them, because your company might not use Kubernetes and doing just fine. And basically, is the GitOps something that requires like specific major or maybe like extra class or bootcamp? I recommend going through documentation, understanding the concept, maybe practicing. All these tools can be installed locally, like Argo, Flux. There's great documentation, but you don't need to be specifically a GitOps engineer. So no, don't worry about it. Just get familiar with basics, and everyone can understand. There's some reading in the slides, and this is basically it. If anyone has any questions, I will gladly answer them.
All right, thank you, Natalie. Yes, you do have questions. So the first question from Gawadi. So he said that he's interested to know how would you set up a project that uses common infrastructure. So the example that you share, put the source code in the same repository as in the infrastructure repository, whether it is actually the industry standard. And if so, would you create a separate repository for any shared infrastructure?
If I understood the question correctly, this is actually, in my opinion, from the projects I work on and I saw in industry. For the Terraform case, this is a fulfilled project the way it's designed. So in my case, this project doesn't have Kubernetes. Like I said, it's just has a source code. It has a Docker file, which is Lambda. So Lambda in some cases can be also Dockerized. And this is fully standard. Obviously, like when you deploy something, when you commit something to your local repository, you don't commit this folder. But again, it's just formalities of the tool. But the structure, yes, in my opinion, this is a ready project to be in production, except if you listen to this talk carefully, I don't have a config for production. So in this case, I would create a different folder called prod. And then from prod, I would configure probably a different bucket, which I can name prod1, or just prod. And then I probably want to tune my login, right? In production, we don't want to have debug logs. So I would probably remove this, and my setup will look like the same, but a little bit different in a way how I want to configure my environment, right? I hope I answered the question.
Yes, Gawadi, you can elaborate more over.
Oh, thank you. Yeah, thanks for the answer as well. I mean, my question is more, yeah, I mean, like with Terraform, I can get that, like, the way it is structured and have a prod one. But my question, for example, like for this application, if it requires a database server, and then there's another project that uses the same database server. So in that case, would we want to put the same code in 2 different projects to create that infrastructure? Or would it be better to create a separate repo for the common infrastructure? That's what I meant. So like, for example, we have 2 projects, both of them use the same database server. So we don't really have to provision that server twice, right?
So shared database is very cool topic. There is a lot of ways how this is good and this is not really good. When I talk about service, I talk about like basic service, where service usually comes with its own database, its own infrastructure, right? So it is, let's say there's one. So shared database is specific question. It's how do you want to design in your company? If service come, let's say, I'm going to give you 2 examples. One, let's say company is using Postgres database specific version. So in this case, in my Terraform, I would say use resource with a specific version. So yes, the resource for that database, I want to put in separate folder, in separate module. And then in my main project, I want to reuse that, right? But I don't have to write this whole config. I will just say, this repo has this module. I want to put, let's say, version of Postgres 3.5, and that's it. So yes, but let's say there is a case where people use Kubernetes, for example, and I don't have opinion on how people designing their clusters, but so far there is like good and bad. Let's say there is a case when you can have entire monorepo of the Kubernetes, right? And all the resources could be just a repos within the repo, like monorepo, right? And let's say you want to build the clusters in a way that the cluster reuses that resource. Simple example is that, say we want to put something in the cluster, like for monitoring, Prometheus. We want to have it in monorepo. It's better when you, let's say, bringing up your cluster with all the infrastructure around it, if you see what I mean, because there's also patterns when they have different things separately. But in my case, if for example, I just have example in my mind. I'm not sure that it's easy to understand, but if we go into the AWS blueprints, and I primarily work with AWS, so I apologize that a lot of example comes from AWS, but what I'm trying to explain is something like this, where you can have a monorepo with different modules because all of them are part of your cluster. And I prefer this when you design something like cluster, right? But when you have a Postgres database, I see the case where you might want to have like a separate module and just add it to the service once it's needed or not that service. So I cannot say this is wrong or that is wrong, because in industry, specifically with Terraform, both of these patterns exist. But there's a way when it's easier to manage everything related to a cluster in one repo. It's just harder to debug something. Basically, if we go back to GitOps and I think about designing the pipeline for my cluster, I would like to have everything in the monorepo, like this current example, where entire infrastructure for one cluster in one repo.
Yeah, thank you. Yeah, that's a great explanation.
Great. Thank you, Natalie. Thank you, Gawadi. Another question we have is from Unita. She's asking whether is the term GitOps designed for Kubernetes and containers?
Sorry, can you please repeat the question for some reason?
Oh, no worry. So is the term GitOps actually designed for Kubernetes and containers only?
No, it's not just for containers and not only for, it's used a lot in the Kubernetes world, and I think Kubernetes is how it got pushed, like how this term became popular, but Kubernetes can be deployed with Terraform as well. And as I said, you can design your GitHub repo like in my, like, let's say in example 4, where I have this Rust in example 3, where I have my Lambda, it uses Docker file, but it could be just a Python, and it's not necessarily need to have any containers. So it doesn't need to be Kubernetes at all.
Okay. And so Natalie, how has the GitOps changed over the past few years, and what would you predict will happen in the next few years? Like, now there's ChatGPT and all this thing. Like, what do you think about what will happen if and how it will affect GitOps?
Well, there is certain already tools in the market where I think if I think about GitOps in the way I presented, that it's basically just addition to my pipeline and my workflow. I like it because there were certain points where I mentioned that we can create alerts, right? And I believe with ChatGPT, we can make them smarter. Some people probably, like I personally, during my life, I have a lot of pipelines I build, right? And I don't enjoy copy pasting a lot of the CI/CD scripts, which are the same. And basically they all do the same. They do publish, build, deploy. And if ChatGPT can eliminate that for me, I'm super happy. If I can say, this is Python app, please design a CI for it. And it will just get me a Python, get me PyTest or whatever needed. It will get me like a ECR code just so I can get my repo and push it. I would love that. Also, I feel like, I don't know how good ChatGPT with Terraform, but maybe can start writing certain Terraform codes or Kubernetes YAML specs, because again, to me, those just like templates. I'm not in the business of learning them still, like I do it a lot, but I don't want to learn these versions, those updates. So if ChatGPT can just, I can say, hey, create me a deployment. This is my latest. This is how much memory I want to have, and it will design this. I don't mind this. I feel like this is not something we should focus on. I feel we should focus more into architecture of the application or like resource usage or monitoring around it, but not the actual like YAML copy pasting. There's a lot of talk in the industry about YAML in general, and how our work as infrastructure people becoming mostly just like YAML parsing and editing.
Yeah,
in my opinion.
Got it. It's like, let's just ChatGPT generate all the YAML for us.
Yes, like the routine work, I would like that to be eliminated from daily routine, absolutely.
Okay, so it's a question from Siti. Seti, sorry. Yeah, so say, I don't think I've ever written a CI/CD YAML script without encountering a single error. Oh yeah, we all do. So what advice would you give to someone wanting to understand DevOps intuitively rather than through trial and error?
Oh, that's a very good question, because when I was preparing this talk, I was thinking about if I can ever make it in a way that, we all have like one template or one standard, but I believe there is no such thing, right? So first of all, when the way I do it, obviously there are different apps, but I just try to do my CI. I usually start with CI. The best advice I can get is that people start like complicating their work by setting up the repo, pushing code. I do everything locally. So I do like to run things locally. And then it's just faster for me, right? And my CI, basically, this is how I start designing any application. So I do want to have tests. I do want to have working code. And I do want to have infrastructure or some dev environment where I can build it. So let's say with Kubernetes or Terraform, all these things can be run locally, right? I run this Terraform pointing my configuration to the cloud, to the S3 bucket, but I could say, hey, don't do this. Let's just start simple and then make sure all these things can be run locally. So again, if you read more on Terraform, you can do that by saying something like local or not providing anything. And then you make it work locally. And then in the end, you just collect, you can just do like, I don't know, history in your terminal, collect the steps which worked and just put it into your CI/CD. Otherwise, you have to push and wait, and then find typos. So I use all these linters too. And there's also like, if you use GitLab, my current company uses GitLab, there's a lot of plugins, but sometimes, you know, you made a typo, you did some mistake and you still have to commit again and wait for it to push. And like some companies uses their own runners. So you have to wait in the queue till the runner become available. So first, the best advice, just make it work locally. Same with Kubernetes over here. I probably, there's a tool called Minikube, which runs all your local cluster, or you can use Kind. I have all of them, which those tools, like I didn't do the demo, but this Argo, it runs on my local host. It's something I do for work, right? But you don't have to wait for Argo. Like if you're working on your pipeline, just install it locally. It's simple, brew install Argo, and then just set it up and like make it work here. You can connect locally to your GitHub. You see, this is my 99 is my GitHub handle. So it's failed right now, but again, I'm just started working on it. So you don't need to complicate your life with that. Once you have all local, you just run history and then you grab your commands. And I think, and then this is what I do. That's why I make files where they represent what I did. So I did it once, I made a note and I just run with this command and that's it. So I do make init, and I also don't have to, I'm not in this folder, but I don't have to run 15 commands, just like it's my history of my previous project. So local development is a big deal, and I know a lot of companies don't have it.
Yeah, you just push and see how it goes.
Yes, it takes a lot of your time if you think about it. Also, if you do it once, your entire team will win because everyone used the same main and just like it's in. Okay, the last thing I probably want to add, very important once you do it, create the README. People stop doing READMEs. Just put this command and I just copy pasted it, right? It just saved me a lot of time. I didn't make any typos, just started running. So.
Yeah, so another question. So what has helped you get to where you are? And what advice would you have for others who want to set off in a similar direction, you know, as you?
I feel like being in the infrastructure field, you can have multiple opportunities. So, and again, there is a Google book on SRE where they define different branches of how your career can go. But basically, first of all, I think if you're working as if you graduate as a computer scientist, let's start from basics. You want to ask yourself what you like to do. Do you like to write the code? Maybe you enjoy doing data and statistics and that. Do you like ops? Because ops also requires a lot of work with people. This is kind of like the reason I chose that, because I do not like to do backend work, right? I don't feel like I want to build something and then iterate on that and fix the bugs and that do it again. I'm not a DBA, so I don't know enough about like data, but I do like when I see the view of the company, right? With infrastructure, so you GitOps, you kind of know what everyone is deploying, you know what everyone is releasing, and you basically can oversee the processes. You can oversee the process of release. you can see some people will come to you with the questions, what database we should use, right? You probably don't know the best ones, but you say, as infrastructure, we offer those 3. Or let's read on AWS white papers or GCP and understand which one they recommend using with this type of service, right? Is it the queue service, is it just a web service, or it's just like some serverless service? And that's why I like I like the infrastructure, because it gives me an idea of like what can we design, how we can expand. And the other part, as I said, like I like to understand what's happening in the company. So I work with QA, I work with that data team, I work with like all the feature people on even designing pipeline, give me an idea what they put there, like how Python code is deployed, how, like I never wrote any Java, but I probably can write a pipeline for Java code, right? I know like versions and GREs and their scale and all these things you just learn because you work with those teams. But some people just prefer like different scopes. So I feel like mine was that.
Thank you, Natalie. Okay, folks, any other questions? For Natalie? Okay, I guess that's it. Oh, yeah, okay, I guess that's it for today then. Thank you everyone for joining us. Thank you, Natalie, for sharing the amazing topic. Great, yeah. And yeah, I think we learned a lot from you as well. And yeah, have a good evening. And bye-bye.
Thank you so much for the invite.
Thank you so much.
Bye.
Bye-bye.